Hello and welcome back to Applied Advanced Calculus. My name is Nathaniel Posesorsky and today we are going to be looking at change of variables, the last topic for this course. So change of variables, what does that mean? Well, simply the double integral of fxy dA is going to be equal to the double integral of f of fuv and guv of the Jacobian dxy over duv dA prime. This little thing we see over here, that's called a Jacobian. A very important concept for change of variables. dA prime could be expressed as du dv or dv du. And the Jacobian, how we calculate it, is we do dx over du, dx over div, dy over du, and dy over div. And it's important not to forget that we're taking the absolute value of everything. And that's how you calculate the Jacobian. So let's now linger on. Let's look at an example right now. So use the change of variables s equals xy and t equals xy squared to compute the integral of xy squared dA, where r is the region bounded by xy equals 2, xy equals 3, xy squared equals 2, and xy squared equals to 3. Well, we know that t is equal to xy squared. So by looking at the region, we could say that t is between 2 to 3. And we know that s is equal to xy, so we could say that s is between 2 to 3 as well. Then, we want to get y as a function of t and s. So we know that if we do xy squared divided by xy, that's the same as saying t divided by s. The x's cancel out, the denominator's y cancels out, we're left with y is equal to t over s. Then, if we want to find x as a function of t and s, well, we're going to do xy divided by y. And we know that xy is the same as saying s. So that simply comes down to s over y. And y is t over s. So x is equal to s squared over t. Now we want to calculate the Jacobian. So we are going to take our x and we are going to do dx over ds. So the derivative of x with respect to s, and that gives us 2s over t. If we do the same thing with respect to t now, we are going to get minus s squared over t squared. Now we are going to do dy over ds. So the derivative of y with respect to s, which is simply minus t over s squared. And then dy over dt is the derivative of y with respect to t, which is 1 over s. Finally, we do 2s over t times 1 over s minus s squared over t squared times minus t over s squared. And all of that absolute value. That gives us 2 over t minus 1 over t, which comes down to 1 over t. So we found our Jacobian. And it's important to remember that this is times our dA prime. And the dA prime, in this case, is going to be ds dt. So the double integral of xy squared dA, which was what they asked us to find at the beginning, well, we know xy squared is just t. So essentially, they're asking us to find the double integral of t dA. And both integrals have a limit of integration from 2 to 3. We found that at the very beginning. So integral from 2 to 3, and then integral from 2 to 3 of t, which is our xy squared, times our Jacobian, which is 1 over t, ds dt. Solve the integral, and you get a final answer of 1. And that's how you solve change of variable problems. I hope this was helpful in better understanding the concept, and I hope these videos have helped you better understand ENGR 233. If so, please leave a like and subscribe. This has been a pleasure. Thank you very much.